Hello everyone and welcome. Have you ever wondered how scientists can separate the different colors in a single drop of black ink? The secret is a powerful technique called chromatography. Today, we're going to break down a key concept in chromatography that helps us make sense of the results, the retardation factor, often called the RF value. Think of chromatography as a race. We have a stationary phase, which is like the racetrack itself, usually a piece of paper or a thin layer on a plate. Then we have the mobile phase, which is a solvent or liquid that moves along the racetrack, carrying our sample mixture with it. As the solvent moves, it tries to pull the different components of the mixture along. However, some components stick to the racetrack more strongly than others. The components that don't stick much travel far and fast, while the components that stick a lot get left behind. This difference in speed is what separates the mixture into distinct spots. So, how do we put a number on how far each spot traveled? That's exactly what the retardation factor does. The RF value is a simple ratio that compares the distance traveled by a component to the distance traveled by the solvent. Calculating it is straightforward. First, you run your experiment and let the spots separate. Then you measure two things, both starting from the original starting line where you first applied your sample. You measure the distance from the starting line to the center of one of your separated spots. Let's call this distance x. Next, you measure the distance from the starting line all the way to the solvent front, which is the highest point the liquid reached. Let's call this distance y. The formula for the retardation factor is simply RF equals x/y. Because the spot can never travel further than the solvent that carries it, the RF value will always be a number less than 1. It has no units because you are dividing a distance by a distance. This simple number is incredibly useful because, under the same conditions, using the same paper, the same solvent, and at the same temperature, a specific chemical compound will always have the same RF value. It acts like a unique fingerprint, allowing scientists to identify unknown substances by comparing their RF values to known standards. It's also a great way to check for purity. If you run a sample and get multiple spots with different RF values, you know you have a mixture, not a pure substance. Thank you so much for watching. If this video helped you understand the retardation factor, please show your support by liking this video, leaving a comment with any questions, and subscribing to the channel for more science content explained simply. Your support makes these videos possible. See you next time.